All right, we have another question here, another FRQ type question. FRQ number 2. And this question doesn't have any picture, but it kind of already has just some information. It does look like it has some sort of equation, but overall, we have more like little pieces of information. So let's see what we can come up with those pieces. Let's start with part A. So in part A, it says write an equation of the tangent line and to the graph of f at the point where x equals 0. Well, every tangent line starts, back to that like point slope kind of thing. But we're going to make some substitutions and a little bit of algebra here. So I'm going to say this is like saying y equals, if I move the y1 over, y1 plus the slope of x minus x1. But instead of y1, I'm going to call that f of x1. And instead of m for slope, I'm going to call that f prime of x1 times x minus x1. Now we actually have all these pieces because we know that x1 equals 0 and f of x1 equals 2. We know that from this first piece of information. And we know that f prime of x1, the slope at 0, is negative 3. So now I just need to substitute in these values. We'll have 2 plus negative 3 times x minus 0. Done. Let's look at part B. For part B, it says, is there sufficient information to determine whether or not the graph of f has a point of inflection when x equals 0? All right, well, they tell us, if we're thinking about a point of inflection, they tell us that the second derivative equals 0. But to have a point of inflection, your second derivative, f double prime, needs to change from either positive to negative or negative to positive. It's got to change that concavity one way or the other. So our answer would be no, we don't know. No. F has a point of inflection when f double prime of x changes sign. And we don't have enough information. Okay. And C, given that g of 0, let's highlight some things in green. G of 0 equals 4. Write an equation of the line tangent to the graph of g. All right, let's kind of come back to this same thing that we did here, but we're going to write it for g. In this case, y is going to be g of x1 plus g prime of x1 times x minus x1. All right. And x1 is like our value. In this case, it's 0. So again, we were going to say x1 equals 0, and g of 0 equals 4. G prime is something that we could calculate from this, but you don't have to even fully simplify it. So I could just say g prime of 0 equals, now I'm just going to kind of fill in that equation, e to the 0, if I plug in 0 for the negative 2x, times 3 times f of 0 plus 2 times f prime of 0. Now, we know that f of 0 equals 2, and f prime of 0 equals negative 3. So we could say that g prime of 0, I don't have to do this, but just to simplify it a little bit further, is going to be equal to 1 for the e to the 0 times, well, the first one is going to be 3 times 2, and then we'll have plus 2 times f prime of 0 is negative 3. This winds up being 0, so you could say that g prime of 0 just equals 0. All right, well, let's fill in some pieces here. We'll say y equals g of x1, or g of 0, is 4, plus g prime of 0 is 0 times x minus 0. Because that's our x1 and that's our g of 0. This whole second term does go to 0, so you could just say y equals 4. And that is accurate. All right, let's look at part C. Oh, that was part C. Did I skip something? Nope. I just forgot to write a part C there. So let's change this to part D. All right, it asks us to show that g double prime of x is equal to e to the negative 2x times negative 6f of x minus f prime of x plus 2f double prime of x. Okay, well, let's start with our original. G double prime of x is going to be the derivative of g prime of x, which is e to the negative 2x. Let's do this like that. E to the negative 2x times, let's see, we have 3f of x plus 2f prime of x. 3f of x plus 2f prime of x. So we're taking the derivative of that whole thing. Now I notice that this looks like a A-B product rule. So I'm going to do some labeling over here on the side. I'm going to say A equals e to the negative 2x. A prime, the derivative of that, it's going to have kind of a chain rule in it, the exponential chain rule. So negative 2 times e to the negative 2x. B is 3f of x plus 2f prime of x, which seems like a lot, but those are basic coefficient rules. So b prime is just 3f prime of x plus 2f double prime of x. Okay, now I already noticed that I have a little bit of matching going on here, which is kind of neat. So that hopefully should work itself out. Let's put together g double prime of x equals, let's put together our product rule. We got a prime b plus b prime a. A prime is negative 2 e to the negative 2x. B is kind of a long group, 3f of x plus 2f prime of x. And then we're going to have b prime a. So b prime is 3f prime of x plus 2f double prime of x. That's a whole group times a, which is the original e to the negative 2x. I notice that I have an e to the negative 2x in common to both of these terms. So I'm going to factor that out. That'll give me e to the negative 2x. And that's going to leave me with this -2 getting distributed into the first group. That'll make -6f of x minus 4f prime of x. And then we still have the rest of this here. So plus 3f prime of x plus 2f double prime of x. We're pretty much there. This final step is just a little bit of simplifying here because these two terms are like terms. They're both multiplied by f prime of x. So I could say that's -6 f of x minus 1 f prime of x, or just minus f prime of x, plus 2 f double prime of x. There we go. And now it's complete, the whole problem. So I'm going to leave kind of the first part here just for a moment. If you want to pause the screen. And then I'll scroll down to show part D in particular, the long part. And that'll do it. Thanks for watching.